And we're live. Welcome, everyone. Thanks for joining us here. It's your favorite host, Lucas, speaking. It's great to see so many of you already. Some names we know. Yair, hello, good to see you. Niels, know that one. Hey, George, Fred. That's great. It's great to see you. We'll wait a couple more minutes. There's a pretty big crowd today, so that's great. Hi, Niels. And so we'll just wait one more minute to let people trickle in, and then we'll get started. Hey, Geraldo, how are you doing? Hey, Tom, you're having dinner. That's great. We're definitely looking forward to dinner as well. Well, just a webinar before that. Awesome. So just a quick round of housekeeping before we're getting started. This webinar will be recorded, and we'll make sure to send you guys the recording either this evening or tomorrow morning for European time anyways. And we'll make sure to include all the materials, the links that we'll talk about today. And if you have any questions or anything that's coming up, we'll make sure to include any answers in there as well. So just FYI, you don't have to take notes. All right, I think it's we're a couple minutes in. We can get started. So welcome, everyone. Today we'll talk about how to scale a team alongside Kubernetes. This is a particularly fun one. We're going to have lots of war stories and fun anecdotes from our two speakers. So I hope you'll enjoy it. I'm Luca. I'm in charge of product here at Humanitech, and I'll be your host today. I'll support our two speakers, Jaakko, who's the CTO of Polar Squad.
Hey guys, my name is Jaakko Palarek, and as Luca mentioned, I'm the CTO at Polar Squad. We are the best DevOps company. That's how I think it is. We're based in Finland and Germany. We've got about 50 people working. Most of us are DevOps consultants. Rest of the guys are admin, like a few people on admin side. We've got about something like 60 clients that we've worked with 80 projects. We're mostly doing hands-on consulting, things like cloud and of course Kubernetes, but we also do advisory work as well. We've been partnered with CNCF for a few years now, and actually I think we were one of the first one, if not the first, CNCF partner in Finland. And myself, I come from a developer background. I've been working on DevOps and SRE for a while now, and working with Kubernetes for a few years, since 2018.
Nice, starting strong. I like it. Yair confirms that you guys were the first ones. And then our other speaker is the CTO and co-founder of Humanitech, Chris.
Hi there, yeah, so my name is Chris, and CTO at Humanitech. So Humanitech is the fastest way to build your own internal developer platform. So what does that mean? It means that you can give your devs a great experience and a great consistent experience across all of your applications and work that you're doing, while being able to, at the same time, on the ops side, manage resources, clusters, and things like that relatively straightforwardly. It allows your devs to do things like spin up environments on demand. They can then deploy directly. You can even automate deployments right through from your development environments through to production. My background is I started out as a software engineer. I spent some time doing product at companies like Google, where I actually worked on some of their internal engineering tooling. Yeah, now here at Humanitech.
Just as a reminder for everyone, as I said, we're keeping it really free-flowing and hopefully as entertaining as possible. So feel free to just drop questions at any time. The format is designed so that we get interrupted and we bring you guys into the conversation. So feel free to ask at any time. And with that, I'll leave it to you and I'll shut.
Thanks, Luca. So we thought we'd kick this off by just kind of explaining the scope of this this webinar. We're going to focus very much on the organizational side of Kubernetes, and we're not really going to dive into the details. So we're not going to talk about the technical benefits or problems with Kubernetes. We're going to talk about how Kubernetes affects the organization, and so how you will scale your team alongside Kubernetes. Hopefully throughout this, the next 30 minutes or so, we'll cover the pros and cons. We'll talk about how to remain productive, maybe on the operations side as your dev team grows, how to stay productive as a developer when your operations team is maybe not growing as fast. And we'll also discuss how Kubernetes is or maybe isn't a good fit for various teams. So why don't we kick off then with some high-level pros and cons? Jaakko, do you have some ideas on that?
Yeah, for me, like the best thing about Kubernetes is the fact that it provides you so many tooling out of the box, that like lots of operational tooling that you can really easily take into use. Things like rolling upgrades and like loading up your application on different nodes automatically when one node fails. All of that sort of stuff. That used to be something that we spend a lot of time on, fiddling about with, but these are the sort of things that Kubernetes just provides for you out of the box. And also as a functional programmer or ex-functional programmer, not sure if I do it that much anymore. What I really like about it is that it has that sort of like declarative way of like building your infrastructure on top of Kubernetes. You declare what you want instead of like push the button to get the stuff running somewhere.
Yep. I think for me, one of the interesting things about Kubernetes is it's becoming a very common platform and becoming kind of a standard across the industry, which from a recruitment point of view, for example, is very handy because it means that it becomes much more reasonable that you can hire someone who already has Kubernetes experience and so can then apply that directly in your company. So your onboarding time goes down, and in theory, the talent pool is getting bigger and bigger and bigger as more people get exposed to Kubernetes and more people end up trained up on it. So from a kind of operational perspective, there's definitely knowledge building within the community, and that is definitely something useful if you're trying to scale your team. You don't have to train them on your bespoke in-house setup or the specific cloud vendor that you're using's technology. And then kind of on the downsides, what are your thoughts, Jaakko?
Yeah, one of the things that I regularly encounter during my time in many of the Kubernetes projects is that it does have a lot of like operational overhead to it, and that's something that surprises many teams like constantly. There's constant upkeep required to keep things updated, keep things running, debugging some weird mystical errors on some component you probably never heard of.
Yeah, I would agree with that. And I think also on the dev side, there's the other thing is that if you're not careful, it's kind of another tool that your devs need to learn. They're probably already, they've got familiar with containers, they're using Docker, maybe running Docker compose locally. And all of a sudden, if you say, hey, by the way, you need to run your code on Kubernetes, or by the way, here is the kubectl, and here is a cheat sheet, go and jump in. Maybe that increases the barrier to having regular deployments and kind of speedy work on the dev side, if you kind of introduce all of this additional complexity on top of what they're already doing. So actually, when we're talking about team sizes, maybe we can talk about how Kubernetes actually scales, or how you would organize your team around different Kubernetes as you are a different size. So I like personally to think about 3 different sizes of teams. So we have your very small team, so usually less than 10 dev and ops people. So probably everyone just does everything. And then you have your kind of medium size, maybe your like 20 to 50 devs. And then you have your larger team, more like enterprisey teams, which are, when you, in my experience, getting to about 100+ developers. Jaakko, any thoughts around how team size affects how you utilize Kubernetes within an organization?
Yeah, something that I've definitely noticed a lot is that in these sort of like really smaller organizations, usually something like startups or something like that, there's like very little ops capacity there. So there's like maybe one person or two people at most doing the ops work. Sometimes there's not even that. There's just some a developer guy who just happens to know a lot of operational stuff from the past, or is just interested in it. In those cases, usually what I'm seeing is that the barriers between people are quite relaxed. So you have like one Kubernetes cluster where everything gets done, and like there's no like permission handling or not a lot of monitoring going on, and it's sort of like really fast and loose that you're playing there. Whereas on the sort of like medium-sized companies, what I've seen is that there's a lot of struggle going on, like trying to figure out the right sort of like scale for how to deploy, like granularity to deploy of Kubernetes to the team. So whether they use like one cluster per team, or is it a shared cluster? How do they handle the permission management? How do they make sure that teams don't accidentally just delete everyone else's deployments one day and then wonder what's going on? Whereas the enterprise customers, they typically have the manpower where they can actually throw in a complete team to just figure it out, figure out how to like do Kubernetes in-house for other teams.
Yeah, I think that that in-between size is very interesting, because you're in a space where you don't have, as you say, this ops power to be able to kind of support a scaling thing, but you start having to do things like break up how your applications are deployed across clusters. And the situation of accidentally destroying the deployed application for your next team because your kubectl has pointed to the wrong namespace is definitely a thing that happens, and probably happens more often than people want to admit, and can be pretty impactful. But I think one of the things that's interesting here is, how do you provide those kind of separations and guardrails for dev teams without slowing the dev teams down themselves? So maybe giving everyone unfettered access to Kubernetes cluster doesn't scale, but at the same time, you don't want to have an ops team that is handing over deployments, say, from a development team and then running the deployments themselves in the cluster, because that also doesn't scale, especially if you're in this middle zone of kind of team sizes. So Jaakko, I think you had some kind of examples of where bringing in kind of teams blocking ops, a blocking team of ops people kind of slow down the development experience of dev teams.
Yeah, it's like you have to some way balance that. Like how do you make sure that things are operationally stable, but at the same time try to give teams the leeway to actually build things that they want to build and not block them. And if you get it wrong, if you get it in a way where the operations people become a blocker for the development teams, then they will start finding ways to get around you. Either they start like going through each other's access, or they try to get through the short paths of like asking on Slack from admins directly, hey, can you do this one thing for me now, please? Or they start maybe even looking into alternative platforms. That I've seen that happen as well. It can get quite messy really fast that way. So one thing that it's sort of like a rule of thumb that I've had is in this sort of world of you build it, you run it, is that the level of isolation should be something where you as a team you can only touch the things that you build, and you cannot touch anything that others build. So if you can achieve that level of isolation, then you're actually quite in a good position in a way.
Yeah, I think if you look especially at larger companies, they tend to build some kind of developer platform around these kind of technologies, so that as a developer, maybe you don't have direct access to the cluster, but you have a very clear and standardized interface that you can make sure that you can get your code up and running in a cluster very quickly with minimal hassle and zero input from the ops team. So it then becomes something where you're very much trying to self-serve the developers, and you're providing exactly those guardrails that Jaakko was saying about making sure that you can only touch things that belong to you, and presumably also only configure things so that they end up staying within the bounds of what the organization wants, be that how you manage your monitoring, or be that security policies around, say, network policies and so on. Those can be applied, and as a developer, it's something you don't need to worry about. You just kind of say, well, I want my code to run. Here's how I get it up and running. And that's kind of a very useful thing in the middle of the scaling thing. It really reduces the developer overhead of working with Kubernetes.
Yeah, and it can be really useful as a way to accelerate the adoption of Kubernetes. Like your platform team, the infrastructure team, that is sort of like, it's maintaining the Kubernetes cluster, but it also like maintaining the tooling for actually utilizing it. And the better the tooling is, the faster the teams can get sort of like onboarded on Kubernetes. That said, I've seen it also like done kind of like in a bit of a poor way as well. So something to be cautious about is if you don't do good enough job for developing the tooling, you can easily get into this state where the developers can do a few things, but it's not flexible enough for all of the use cases they want to do. And in those cases, if you don't have an alternative, like if that's the only thing that you can do, they suddenly become frustrated because it makes sense because they can't really Google for solutions for your internal tooling, right? So it can be really frustrating when suddenly when the tool doesn't work for you, now you start to have to actually start from the scratch on starting to learn back from the basics on how do you actually get to do what you want to achieve. Even though it might be possible, it might be that there's a whole lot of way to like knowledge to learn first, and that can be really, really not motivating thing for developers.
No, I definitely agree with that. Maybe we can also have a look at the ops side. So we've talked very much on like a developer experience, but there's also kind of the operational experience of running Kubernetes. And we've already talked about the operational overhead. One of the things that's really interesting, especially in the last couple of years, is now the maturity of the various forms of managed Kubernetes, be that a fully managed system like using GKE or EKS on Google or AWS, or be it using some kind of alternative managed setup, like, for example, Kubernetes through OpenShift, or maybe using Rancher or something. Jaakko, your preference when you're talking to your clients is managed Kubernetes, or should they be running their own clusters from the latest upstream branch?
So for me, what I've seen is that if you're already on a cloud platform like Google Cloud or AWS or Azure, you really want to look into that the option what they provide you for, so EKS, GK, and so on and so forth. Like they are pricing wise, they are competitive compared to just running your own cluster, and you get a lot of like managed stuff taken care of, like a lot of the operational tasks taken care of for you. Things like the etcd backups and other sort of like control plane management parts that you just don't have to care about it. Like they're just taken care for you. So considering that, it doesn't make a lot of sense to run your own Kubernetes cluster really on top of these platforms. I can only think of like a few edge cases. things like, let's say that you really want to hook up your Kubernetes cluster to Active Directory on AWS. In that case, EKS doesn't really have a solution for that because it requires the IAM for authentication. But those are like really, really edge case situations. But yeah, other than that, I would just go for what the cloud platform provides. They're quite stable, in fact.
Just jump in real quick here. There's a lot of activity going on in the chat, so maybe we can answer a few of those questions.
Sure.
I'll start from the bottom. Niels is asking, would you recommend to set up multidisciplinary Scrum teams, including DevOps experts, or would you recommend to have a separate DevOps team to support your development teams?
Yeah, I could answer that. So I've seen both done, and it kind of depends on the situation, really. If you're talking about the Kubernetes context specifically, what I've seen to be quite successful is that you have like a platform team. So that would be the sort of like DevOps team in a sense. So this platform team would be responsible for like providing Kubernetes as a service for the development teams, providing them the support, providing them the access, and providing them the tooling to actually use it, and spreading the knowledge around within the whole organization on how to use it and how to get onboarded. That's been one really successful way to get on Kubernetes. You start with our platform team, make sure that they have a solid practice for keeping the Kubernetes clusters up to date, and they one by one they can start working with teams on getting them migrated. But the teams themselves, they take care of their own software deployments, their own production deployments. Now that doesn't necessarily mean that you cannot have like the infrastructure engineers or cloud engineers or whatever DevOps expertise embedded into the teams, but usually you can get by with like having the infrastructure people in a platform team, sort of like behind an API in a way. But the important part, I think, is that like the platform team doesn't become a ticket board for the developers. Like, hey, I need to do this like thing to get my stuff on production. Go do it. Like that doesn't really work that well, quite far, in my opinion.
Yeah, I would agree with that. I think the key point here is to really think about what DevOps means in this kind of concept of you build it, you run it, which is, as we mentioned before, a little bit abused sometimes. But fundamentally, the idea is that your developers should be able to self-serve and be able to run the software development lifecycle themselves without having to jump and kind of ask permission or send tickets to someone to get something done. So I think the key thing is, as long as you're enabling that self-service, then it's a positive setup. And in practice, especially as teams grow, having a centralized API, if you will, of a centralized team that actually manages the platform, it really does provide that self-service piece. And effectively, rather than becoming a ticketing board, which is definitely an anti-pattern, the ability for developers to actually build on a platform just as they would build on standard libraries or build on any other kind of structure within a software engineering world, I think becomes really powerful. So the platform then becomes an integral part of your software stack rather than becoming the kind of mythical land over there that you need to pay your dues to the tickets system to go and get your code up and running in it.
Exactly. And I think just to add to that is that once you get into this sort of mindset where development teams themselves are like maintaining what they build, suddenly they start to think about, okay, well, if I have to maintain this, then I probably don't want to run something that I'm not sure I can support. So you get to this sort of like situation where they really start to think about the operational complexity of things as well. So suddenly maybe they don't want to run the hot new graph database or something like that they just saw on Hacker News the other day. So maybe they are, they can run by with Postgres like on RDS for now.
All right, so Apo is asking, when hiring these new team members that you guys were talking about earlier, would you rather look for CKA or CKD, which I think is Kubernetes certified Kubernetes administrator or certified Kubernetes app developer, or would you rather just check their GitHub history, and that would matter more than a certificate? A few people seem to don't like the certificate.
So my kind of take on that is that certificates are great. It's a great structured way of learning and provides value. Like you show that you actually know what's going on. I still think that even though Kubernetes is growing and it's becoming more of kind of a ubiquitous setup, it is still quite early on. So there's a huge number of people with a lot of experience in Kubernetes who haven't done the certification and probably never will. They were like, well, I was here from version 1.10, I've been using every version since. Why do you want me to fill out a certification? Which is entirely fair. I think it'll end up being more similar to how you saw or how you see software engineers being hired. So if you go back even kind of 10, 15 years, the chances are that maybe someone has done computer science, maybe someone did mathematics at university, maybe someone didn't go to university and just kind of picked it up. And you end up hiring people based on kind of their resume experience rather than whether they have a computer science degree or not. I think nowadays, as things are changing, more and more people are training up in terms of software development and doing like formal programming courses and ending up with certification that way. So the market is changing. And I think you'll probably see the same thing happening over time with Kubernetes, where over time, as it becomes more formalized and more standardized, it becomes part of curriculums, for example, and there's a wider set of certification and more people have done the certification, then maybe there should be more weight. At the moment, I wouldn't take certification as a negative signal. It's a positive signal, but it shouldn't be the only signal.
Yeah, for me, it's like the certification is sort of like a base level of knowledge that I can sort of pretty much account that you have. It's sort of like having a black belt. It's sort of you've gone through the basic training, but it's not a replacement for actual real world operational knowledge, I'm afraid. And that's something that you only get through like actually working with Kubernetes throughout the years and actually experiencing it and learning from mistakes of yours and others.
CJ is asking, if development teams aren't mature in the Kubernetes or even container space, how do you set up the guardrails to allow them the freedom to learn without introducing more risk to the organization? That's a good question.
Yeah, that's a really good question. So one is that you want to have a Kubernetes environment for them that has enough of the sort of like guardrail software and add-ons installed to it that you're confident that whatever is being done there is sort of like it cannot really escape into other teams' world. So either you have like a dedicated namespace with all the network policies, or like mutating webhooks to make sure that things are not run as a root as a root, or maybe you even have a completely isolated cluster just for the sort of like beginners, especially if you're using it as a like a training ground. Especially then you want to have like separate clusters for that purpose. And I think one of the biggest things that you can do is you can just acknowledge that, hey, things are going to go wrong. There's going to be mistakes in the beginning, and you account that into the actual software itself and everything else that is surrounding to it. That there might be something coming from there that might break things, and you just prepare for that. Right now, like if you're doing like multi-tenant stuff, the isolation is kind of like not quite there yet. There's certainly some tools that are being developed. Things like what was it called? Kiosk. That's something that is sort of like built to properly manage namespaces for you. But right now, it's sort of like not really sure if it's quite mature enough yet. So you kind of like have to, in many of these cases, figure it out for yourself.
Yeah, I would kind of follow on with that. So one of the things to do when you're thinking about kind of immature teams or guardrails is also to try and divide the problem down. So especially if you say a team is not even necessarily particularly mature with containers, then maybe you want to split things out and say, well, actually, dev teams, you focus on containerizing applications, work out what a well-factored containerized application looks like, understand how to build them, understand how the tooling works, and make sure you have a very well-structured, for example, continuous integration pipeline set up, and a consistent way of ensuring that you know what containers you're going to be running where. And then maybe you split that and say, operations team, you're going to look at the Kubernetes side and really get an understanding of that. Obviously, you need something to join to get the middle. Usually, that would be some kind of internal developer platform. It would be a good choice here, because what it does is it really separates that complexity out, so you can limit the amount of new stuff that each team has to deal with, which will overall increase your stability. And then the other thing that I think is a great follow-on from what Jaakko was saying about, as well as doing the separation of concerns, is have a system to allow you to manage what configuration has gone into a cluster and then be able to roll it back. If everyone is kind of freestyling it, then if something breaks, it's very hard to work out what broke and how to roll it back. So just like you commit your code to a source code repository, you should be committing your Kubernetes cluster configurations in some way that makes sense within your organization, so that you can return to a good known state, or you can investigate why something broke by comparing it to the last known good configuration. And that should be something that you can very easily apply and take back.
I think we can get to one last question, then you guys can go on with your talking points. It is asking what sort of team should move into Kubernetes?
What sort of team? I think like the precondition for adopting Kubernetes is that you have you first have to know containers. I think that's a given. But the second one is that you kind of like have to have some sort of like base level knowledge of how do you actually run things on Kubernetes, and how do you sort of like manage and debug things on Kubernetes. I think that's really important to have. So have a sort of like a feel for what does it mean to actually run things there, not just like read a book, but actually experiment on things. So like I mentioned, the training ground for that is quite a nice way of like doing it in a sort of like practical way. So experimenting with things, like seeing what happens if you upgrade your software, see what happens when you shut down one of your application pods, see what happens to the traffic if you modify your software a little bit here and there, see how you can find the logs, metrics, all that sort of stuff. I think that's quite valuable, because Kubernetes itself brings in a new way of like operating your software compared to, like, let's say a virtual machine based deployments. So you might have to learn a few new tricks in a way. You can't reuse all of them. So yeah, that's what I would recommend, is having to go through that before going to, like, let's say, production with Kubernetes.
Yeah, I would actually take one step back and ask the kind of elephant in the room question of, like, do you actually need to go to Kubernetes? So unless there is a strong business need, and as in the business of the software you're developing needs the functionality that Kubernetes offers, then maybe this isn't necessarily what you need to go. So if you have a mature setup that's running on ECS or something, that's fine. It'll probably be fine, and there's no need to migrate to Kubernetes unless you're trying to take advantage of some of the functionality that exists in it. So I would definitely echo everything that Jaakko said, is that not only should you want to have a need for going to Kubernetes, but the need should be enough that you've already spent the efforts in actually understanding how it works and how it would impact your teams. I think piloting with a small part of the organization is very important, and then scaling that out within the organization. So it's very much a change management system. I know that sounds kind of boring, but rather than anything else, it looks most like a kind of large-scale change management system or replatforming job, which is usually something which puts everyone off. Kind of rightly so, because it can be a big deal, but you have to really want it in order for it to make sense for your team, I would say. Don't do it on a whim.
Yeah, that's actually something I would echo as well. Like if you already have Kubernetes, then by all means, like transition parts of your other teams to Kubernetes as well to get that sort of like synergy between the teams. But if you're happy with whatever setup that you already have, and you're quite confident that you can run with it, especially if it's just one team, like one team building one software, then a lot of times maybe Kubernetes is not the thing that you need, because like we said, it brings a lot of like operational complexity to your system. So what I really think is that Kubernetes is really nice for like microservice architectures, because it provides a lot of tooling for easily spinning up new applications, new small applications, scheduling them on arbitrary nodes with load balancing in them built for those, and having like this sort of like service discovery within the cluster. But if you're not going to need any of those features, then you probably don't need Kubernetes after all. Like it might be that you can just get by with ECS or even just Beanstalk or something like that.
Yeah, actually, we were chatting earlier, Jaakko, we were talking about the kind of relatively common scenario of having a trailblazer who introduces Kubernetes in an organization, gets everyone fired up, and then that person either leaves the company or maybe moves to a different department, and then you end up with this kind of unsupported kind of technology that no one really takes responsibility for, nobody updates, and very soon your kind of fancy new technology has become a liability rather than something that you're actually using to improve the quality of your software, improve reliability, improve development experience, and actually it becomes worse than all of that.
Yeah, precisely. Like I've seen a few cases where someone just got like Kubernetes mad and wanted to do Kubernetes, and then they did it. Then they got bored with it, left. And now suddenly you're in a situation where you're running 1.6 of Kubernetes, and you got 10 releases to roll forward. Your software is no longer supported. You're running containers for your control plane components that are no longer hosted on any public repository. So you're the only place you can get the software from is like from your local host cache. And you kind of like have to start figuring out how do I actually host this one thing that is no longer even supported in somewhere safe, so that suddenly my cluster doesn't crash and burn in a blitz second in a Sunday. So yeah, it's like you really need to put in the effort to make sure you have that sort of like continuity for the operational support of Kubernetes. Like it really needs that.
Yep. And I think actually we talked about even the managed setups before. Using a managed solution like GKE or AKS or Azure or something is not a panacea for this, because although the cloud providers will do a good job of making sure that there's an easy upgrade path and so on and so forth, you still need someone looking after it and someone managing it. Even a managed setup can go stale or start misbehaving if no one is responsible and no one is actually looking after it from the operations side.
Yeah, exactly. Like EKS has you have to manage the node upgrades yourself. You have to manage the component upgrades still yourself within the Kubernetes cluster. EKS only manages the control plane upgrades for you. So even then Kubernetes is bringing like lots of like things for you to maintain. It's not a fully managed solution quite yet.
Yeah. So I guess going back to the question, it's only do it if you really want to do it and you can support it long term, right?
We have a few more questions that came in, so I think you guys won't get to any more talking points. I think we're just
Okay.
all right. So CJ is asking another great question. So how would you recommend doing infrastructure as code or GitOps, but kind of like avoiding a dependency on tools like Rancher? Any thoughts there? Tom is then sharing a server provider for Rancher 2, and CJ is responding, this works well for managing the Kubernetes plane, but I'm more referring to the secondary clusters that Rancher manages. It's hard to make those as code and then link them to Rancher environments since the process is rather manual beyond hooking into the Rancher API.
Yeah, this is kind of like taking a bit more dive into the technical side of and really like product detailed side of things. My experience with Rancher has been that it certainly makes like installing Kubernetes quite nice and easy from the sort of like clickety-click perspective from the web UI. But yeah, it does have a few of these like areas where it kind of lacks in the infrastructure as code department, and annoyingly it kind of like lacks on the sort of the immutable infrastructure side as well. Like it's very much mutating hosts kind of way of working.
Yeah, I think if we zoom out from like this particular technical example and just kind of look at in a more general case, again, it's kind of all about working with interfaces on a kind of process perspective. So like putting Rancher to one side, any of these workflows need to be very carefully managed so that they do scale. So you're looking at consistency of experience for developers and familiarity of tooling for the ops team. So putting in place something over the top that is consistent. So either developing your own internal platform to actually manage this for you is a important point. And so in this case, maybe using the Rancher API is the way forward, but you want to provide guarantees up the chain so that people can plug things in. So I can run as a developer, I can run things through a GitOps type approach. And then you have your platform hooking in at the end to say, okay, well, in this case, we do this, in this case, we do this, in this case, we do this. From the developer perspective, it all seems very imperative and very clear, which is great. And from the ops side, you have some glue to stick everything together, but you are managing that and you're actually running that in a way that is self-consistent. Now, obviously, the caveat is what we've been talking about before, that you don't want to just like end up building a whole pile of scripts, which end up breaking and causing problems and ending up with people having to work around it. So it's probably a good idea to look at solutions that are out there that already kind of solve these kind of setups. And if you are looking at and maybe even questioning whether you want to be going for a more of a managed setup there, where there's maybe better tooling, or whether you want to be looking at some different kind of Kubernetes setups that would be better suited for the kind of workflows you're aiming for. In theory, every part of your pipeline should be a choice, and you should be choosing the best thing for it. Obviously, within the constraints of like ripping everything up and starting again, which is probably not feasible.
Yeah, something that I've noticed that the story for like automating all of these toolings it's not quite there yet, and a lot of times, in many cases, when I enter customer cases, it's very customized setups that everyone has. In some cases, you can find like a common tool that somebody's built and get to start using it. But in many cases, you kind of have to, figure it out on the fly, unfortunately.
So Alp is asking, what's something you would have liked to know but didn't in the beginning when you began implementing Kubernetes solutions in your teams?
Fortunately for me, I've always jumped into the middle. Like there's somebody actually been using Kubernetes already, and I've sort of like come in and start looking at things and how to fix things. But well, something I've noticed that is that a lot of times the sort of like smaller companies, the smaller organizations have figured out that Kubernetes is nice, it works and does its job, but there's a lot of things to manage there, and well, I'm sort of like repeating myself in a way now, but like they could have also done it, with other tooling on the like cloud platform that they were already using, with a little bit of extra development work. They could have get it done, but with a lot less operational work.
Yeah, I think the key thing that I wish I had realized or known before I started is the fact that Kubernetes is an operational tool, and in theory, it should be an implementation detail. So if I give you kind of example, so going back to, for example, building tooling inside Google, they don't use Kubernetes, they use the precursor to Kubernetes, but there is a whole pile of tooling that's built up on the top. And as a developer, most of the inner workings and details of how that system works are kind of abstracted away and not something you really need to worry about unless you have a specific use case. And so that is an example of a very mature stack and a very clear developer experience. You come to Kubernetes and you don't have any of that. You are literally using the low-level operational structure of how to do all of this, which is cool if you're into that kind of thing. But if you're trying to develop something, you very quickly are like, surely there should be something that just like deals with this for me so that I can focus on getting my code running. And so I guess that's one of the reasons why Humantech now is here.
Yeah, something I noticed that rarely a lot of companies are in the business of actually building Kubernetes. They're in the business of building their software. So like they don't want to get into managing too much Kubernetes stuff. They want to focus on building their software and running that instead.
That's great. All right. Well, thanks Apple for all the questions there. Rizwan was asking, with managed cloud run containers and functions, I would also like to ask the question: would you scale your team first and then move to Kubernetes, or start the migration? I think that's an easy one.
So if I understand correctly, like build a team first to run something, like get something done, and then move on to that team to Kubernetes. Is that correct?
Yeah, that seems to be the question. Yeah.
Yeah. Okay. So I would focus on like getting stuff done with whatever the tools that you're already comfortable with, instead of like jumping onto Kubernetes first. Especially as if you're a startup, you're most likely strapped for cash, so you got to get something done, and you don't want to be spending that time on Kubernetes, for sure not. So if Kubernetes is already in your blood, if that's already something that is familiar with everyone, then yeah, okay, sure, why not? But like if that is not in your DNA, then yeah, go for whatever the tools that you've already been comfortable with. There's no shame in that. If you're doing like a Java EE or something like that, if that's the best then by all means, like there's tons of really cool software built with that. What is more interesting is what do you get out of that? Like what's the sort of like product that you get instead of the technologies that you use?
Yeah, I would agree. I would actually take a step back and look at it as an engineer. So like when you're a junior software engineer, you'll almost always have a senior engineer review your code and say, have you ever heard of the Yagni principle, or the you're not going to need it principle? So this is the principle of not generalizing too early for a use case that might never exist. And the same thing, there's also the very famous keep it stupid simple, I think is possibly a way you say it, but the KISS principle, which is about, again, the minimal amount of complexity is the thing that's most likely to work. And I think that applies just as well for when you're writing software that's running in a container as it is for designing your infrastructure setup. The more complex you are, the more kind of use cases down the line that you start thinking about before you actually solve the problem at hand, the more likely you are to trip up. So just exactly as Jaakko said, I would default to actually building something that works. And then if the business need requires you to move to Kubernetes, as we mentioned before, that's the time to move across. Don't try and like learn a whole load of new technologies with marginal benefit for what you're doing right now if you don't need to.
Like to do the move to Kubernetes. In a situation where traditional ops and dev teams are in separate silos, how would you guys suggest you approach that migration? It's a CJ question.
So what I always recommend is that you some way find a common ground with the between the development and operations teams. Like find out how do you make that function? How do you make those two teams work together instead of working against each other? Because often that's the case. Like often what you have is like, operational teams have their own motives or what they want to do. They want to keep production stable, whereas the developers, they want to get stuff shipped as fast as they can. So how do you make those two meet together? Sometimes that might be that you join the team. Sometimes it might be that you restructure the teams, or give them a different purpose, or give them different responsibilities. So I think that is quite important. If those two teams are dysfunctional, then no matter how much Kubernetes you bring in, it's not going to fix your problem. You really need to figure out the organizational problems first.
Yeah. And I would actually say that bizarrely, Kubernetes might be a good excuse to do that shakeup, because like entrenched culture and entrenched kind of team structure is very hard to overcome. Like making that a change to just say people, hey, you now need to work with each other, is very hard. If you introduce the technology and also say, when you're working on this technology, this is the mode of operation, and actually build teams around that workflow directly, then there's a lot more opportunity from an organizational change perspective to bring people on board and actually allow them to work together. And I think this also touches on kind of selling Kubernetes as a technology within your organization, because if you're a load of devs and a load of ops people, maybe the ops people are super excited by the new shiny tech, but the dev people are like, oh, this is going to be another thing that ops are going to bang us over the head with, because we're not able to generate the right manifest to deploy this in the right way or so forth. So actually bringing it in as a kind of collaboration and really making sure that everyone is involved right from the start of the introduction might be a way of actually breaking down some of that entrenched culture. Because generally an ops versus dev culture, firstly, it's very old school. It's not the modern way of doing things, but also it leads to kind of more of a toxic environment within organizations over time.
Tom is saying he would look for developers ops who are excited to be working on something new and then build a Kubernetes platform together. That way you can convince other colleagues more quickly.
Yeah.
Perfect. Awesome. All right. Do you guys have any more questions? Or do you, Jaakko and Chris, want to do any sort of final remarks? We're already ran over time, but we are happy to keep going a few more minutes. If you guys have any more questions you want to ask, feel free to drop them in the chat. Otherwise, there's one more question that we skipped earlier. Let me just go back to it. How do you address a skills shortage when trying to onboard a project with multiple teams to Kubernetes? That was the very first question asked.
Yeah. So something that I've seen in companies where they're like bringing Kubernetes into the organization. And obviously, it has to start somewhere. Like not everyone is suddenly like a Kubernetes experienced developer or something like that. So how do you do that? And there's a couple of ways that I've done it. So one is that there's that core group of people. It might be like the infrastructure team or platform team, or it might be a slice of people from different areas working together to establish that. So like, how do they actually want to use Kubernetes in the first place? And from there on, end, they start onboarding like teams one by one on the Kubernetes. What I've usually done is I've designed some sort of like base training program, which is usually something like, hey, do these Kubernetes exercises on your Minikube or on your laptop or on a training cluster somewhere. Like you just need to download kubectl and you're ready to go. And follow these steps. It's usually like something like half a day thing maximum that you need to do that. And already you're sort of like getting involved into, okay, I see how this works. And developers are quite smart. They pick up quite early on, like, okay, I see how I could use that. I see how I could integrate this into my, integrate my application to this, and how I could integrate this into my deployment workflows and whatnot. And once you get like that one team onboarded and get a really good success story from that, suddenly word will start spreading around. And if they find it like really easy to use, really easy to deploy to, and manage things for them that they no longer need to manage. I mean, that's like you're taking a load off from that team, and suddenly more people are interested. Hey, could I actually get into that myself? So that's been a big boost. And for the parts where you have like these, sometimes you might have people who are like they just don't want to learn anything extra, and in those times you kind of like want to look at the newcomers that are coming into the company, the new minds that you can kind of bit shape up, to your needs, and kind of like get them trained first and show that, hey, we got these new people, they are doing like all this new cool stuff, and show to the veterans in the company that hey, these are now more experienced than you are. Suddenly that might spark a fire, say, okay, yeah, maybe I should also learn this stuff too. And something like, and this is more like on the sort of like DevOps mentality of you build it, you run it, is that how do you introduce that into the company? Is that you start morphing your recruitment specs already. Like instead of like focusing purely on like, let's say, coder profile, someone who has had extensive experience in coding, maybe you might drop in some requirements on how to use AWS or how to use Kubernetes or something that showcases that this person has actually spent time running their software, not just writing it.
Yeah, I think that critical mass of skill set is really important. So like Jaakko was saying, that you need this group of people at the start who are enthused and able to support and build it out. I think something just to kind of think about, we talk about skill shortages get bigger, especially for large organizations, you can't enthuse everyone, and you will never be able to enthuse everyone. So you then need to think about how you scale these things without kind of falling into the pitfalls we talked to before about, with ops becoming a ticketing system for deploying to Kubernetes and all that sort of thing. So when you're starting out, you can definitely get by with this enthusiasm part, and that will take you a long way. But eventually you're going to end up with the fact that you can't hire everyone with the Kubernetes expertise. There are some very, very skilled people who are working in very specific areas. And as you get bigger, your engineers are going to become more specialists, because that's kind of what happens. And eventually you're going to have to work out how they can still self-serve without also going in and becoming Kubernetes experts themselves, because maybe they're not interested, but also maybe they just don't have the time, and they want to focus on what they do and what they do really well, which is why you hired them. So you'll need to have some kind of plan once you started the rollout and it's kind of embedded, for how you then reach these more established teams, or as you grow, how do you bring in people who are not going to be Kubernetes experts? And usually that is when we get to a transformation we talked before, where you end up with a platform team that is actually providing a kind of API for the rest of the company, so that they have a much lower difficulty with dealing with, like, lower cognitive load for how to deal with Kubernetes, as an engineer just developing a particular service somewhere. And an IDP, internal development platform like Humantech would be an ideal choice, obviously.
Shameless plug. All right. I think we can take the last question of Ishfaq. He's asking, or she's asking, how would you feel about no-frills single node clusters that each team uses and not worry about multi-tenancy? It is almost always that multi-tenancy is needed for development clusters and not actual production clusters.
I mean, if you can manage that, then sure, why not? And if you understand the like issues that you might get out of it, and you have a plan for how to tackle that, then sure, why not? If your problem domain allows it. Like I think like for example the K3S KES or whatever it's called from Rancher Labs. I think that's like a good example of like where they're kind of like providing that sort of really easy one node access to your nodes just to get things running on Kubernetes. And I think that's a like brilliant idea, especially if you can like tolerate the absence of that one node. Like I mean, you're doing like a single node Postgres perhaps even right now. So why not like Kubernetes?
I would just throw in one warning there, where we've worked with a number of companies that had a very specific problem, which is trying to spin up their entire setup on, effectively a single node cluster or a Minikube or something on a kind of local setup. So each developer has their own space. That's great, but at some point, they had to buy bigger and bigger laptops or bigger and bigger workstations or bigger and bigger VMs to actually host these clusters. And that's then also doesn't scale. And so at some point, like you will not be able to spin up all 37 microservices on the same machine, on a single node, and actually have it work in any kind of performant way or even work at all. So this works well at the time, especially if you're able to develop on a subset of your application. But in practice, a lot of teams end up with kind of lots of dependencies between all the services, and it becomes very difficult to isolate a small enough chunk to actually be able to work on it in this manner. So I would say, yes, if you could do it, but beware of the having to buy bigger laptops problem, which is real.
Yeah, and also like is it something that operationally is something that you can manage? Like, are you prepared to deal with the fact that you have now like huge amount of clusters that you need to manage upgrades for? And that's a serious question. And for many, they skip that question entirely and then figure it out later on that oh crap, we cannot actually do that.
Yeah, but then again, looking in terms of these guardrails, a lot of these guardrails can actually, that we've been talking about earlier, can actually help alleviate the problems of multi-tenancy. There's a kind of hard multi-tenancy and then there's soft multi-tenancy. So for a dev environment, you're very much more at the soft multi-tenancy area where you don't want teams to fall over each other, but you're not worried about teams going rogue and trying to kind of negatively affect other workloads running in the cluster. So especially for a dev environment, maybe actually if you set things up correctly, if you have a good structure, you have sensible policies, maybe you have some kind of internal development platform running, then actually that will alleviate a lot of the negative elements you get with these multi-tenancy bits, at least at the softer end, like for shared development environments and so on, without having to maintain like 150 clusters.
All right, guys. There's no more questions coming in, so we're 4 minutes over the hour. So I think we can wrap it up. I'm sorry for who's joining now, because for some reason the number of attendees is still going up. But thanks everyone for joining us and your questions. It was a great conversation. Thank you, Ishfaq. Thanks, Geraldo. All right, we'll follow up with everything in an email. And have a great evening, day, wherever you are. Bye, guys.
Yep. Bye.
Bye. Thank you.